We've graphed the function m of x equals x squared plus 5x plus 6 over x minus 3 using pre-calculus techniques, finding the zeros at -3 and -2, finding the vertical asymptote at x equals 3, and determining that the function is negative in this interval, positive in this interval, negative in this interval, positive in this interval, that it approaches infinity as you go to the right, but along a line that makes pretty close to a 45-degree angle. Actually, it's asymptotic to a line that makes exactly a 45-degree angle with the x-axis, and negative 45-degree angle with the y-axis, with the x-axis, as it approaches as x approaches negative infinity. Okay, we've done that. That's the pre-calculus level. Now we're going to apply calculus to find the relative max and relative min. And we've indicated the relative min and relative max as we would estimate them, pretty close to -2.5 here, and we're not sure here. This is a little vague. We don't have any specific points on this part of the graph at this point. We've indicated the level tangent lines at the relative min and the relative max. So now we're going to do the calculus. We're going to set m prime of x equals 0 at the critical points. Now before we can do that, we have to take the derivative. So you should take derivatives of this. I suggested that at the end of the last video, and hopefully you did. And if you haven't, you should do it now unless you're very, very confident that you can find this derivative. Most people in the course at this point are still a little bit shaky, but I think if they're careful, they can get this derivative without error. Okay, well, how do we do this derivative? Hopefully you've done it. Hopefully you've at least thought through how you would do it. But this is a quotient of two functions, so you're going to use the quotient rule. And I'm not going to write down the quotient rule. You should be very familiar with it by now. I'm just going to write down the result. It's derivative of this. Sorry, derivative of the numerator times the denominator minus the derivative of the denominator times the numerator over the square of the denominator. And that's going to be, writing it out in some detail, okay, derivative of the numerator times the denominator minus, excuse me, the derivative of the denominator times the numerator divided by the square of the denominator. And that equals, and this is of course your m prime of x, equals this. So the derivative of x squared plus 5x plus 6 is 2x plus 5, multiplied then by x minus 3, minus 1, derivative of x minus 3 is just 1, times x squared plus 5x plus 6, all that divided by the square of x minus 3. Now if we multiply this out, and I'm not going to do that on camera. You should do that. I'll do that off camera. But you're going to get a negative x squared, but here you're going to have a 2x squared. That's going to give you an x squared, right? Here you have a negative 5x, but you're going to get a 5x here and a negative 6x here. So I think that's going to give you 4x. And you have a negative 15 here, and a negative 6 here gives you negative 21. So that's kind of a speculation, but let me do it carefully, and then you do it. Write it out, make sure you know how to do this, make sure you get the same result I do. Okay, I've gone ahead and expanded the numerator. And you can check me. You're going to have a 2x squared here, you're going to have a 5x, you're going to have a negative 6x and negative 15. I think that's what I've got. Then you have a negative x squared minus 5x minus 6. I think that's what I've got here. 2x squared minus x squared gives you x squared. 5x minus 6x minus 5x gives you negative 6x. 5x minus 5x being 0. I think I said negative 4x because I was doing something ignorant. Negative 15 minus 6 is negative 21. and then that's going to be over quantity x minus 3 squared. That has to equal 0 to get a critical point. The only way that's going to be 0 is if the numerator is 0, and of course the denominator can't be. Formally, we multiply both sides by the denominator with the caveat that the denominator cannot be 0, so x cannot equal 3, but none of our solutions to this numerator equal to 0 give us 3. So we're safe, and it turns out we'll be safe in doing that. So we get then x squared minus 6x minus 21 equals 0 using the quadratic formula. If I used it correctly, we get about 7.98 or negative 2.48. And I did those estimates in my head based on the square root of 120 being about 10.95. And there's some rounding that's involved, but I think those might be kind of okay, but probably a little fuzzy out here in that third significant figure. Okay, now does that match our graph? Well, negative 2.48 is almost negative 2.5, which would be halfway between the 3 and the 2, and the way this graph looks, our maximum would probably be about halfway between negative 3 and negative 2, at least the way we drew it. In order to come up with this angle, go through 3, then negative 3, then negative 2 on the x-axis, and then through the negative 2 here before diving down into the depths at the asymptote. That makes good sense. And, 7.98, well, there are a lot of ways we could have drawn this. That's perfectly plausible, but there's no way we were going to make a really good estimate of that when we're just drawing the approximate graph. Okay. So it seems like we might have good values here. Now all that remains is to take the second derivative. Okay, well, that's going to be kind of a royal pain. Not sure we're even going to do it here. But I'm going to go off camera, and I probably will go ahead and write it out.